1. This is our Precalculus Fall 2019 ACP Preview Problem 15, which is a Newton's Law of Cooling program. You may not be able to tell, but I have an audience with me today, my Precalculus students from 5th period. We have Hannah, we have Will,
Yes, sir.
and not to be forgotten, Mason. That is Mason. So you may hear our friends. Anyway, we're trying to solve for t sub 0 because that's what we're being asked, and we have this long formula with all these things in here. So let's go ahead and set this up. We're going to have a final temperature of our cookie that is cooling of something 48 degrees. So 48 is equal to the temperature of our medium, and the medium temperature is 20, and we have plus t sub 0, and t sub 0 is what we do not know, minus t sub m, which is 20, it's the medium, and we have e to the negative k, and that k is 0.35, and we have t, which is after 5 minutes. So we're going to find the initial temperature by solving this equation. So we can do this with a calculator pretty easy. I'm going to go ahead and kind of work it out by hand first. So we have on the left side now 48 minus 20, which is 28, equals t sub 0 minus 20, and we have e to the negative 5 times, I'm just going to write out 5. Okay, so we can actually, our unknown is right here, so we can divide by e to the negative 0.35 times 5. And so they will cancel out. So that cancels that. And so what we have left is t minus 20. And now if we add 20 to both sides, we're going to have t sub 0 is going to be equal to 28 over negative 0.35 times 5. That's going to be e to the negative 5 plus 20. And now we can just put this in the calculator. And here's our TI 84. Make sure I get this right. 28 over, okay, got that. So we get a division here. 28 over e to the power of, second, there we go, e to the power of negative 0.35 times 5 for 5 minutes. And let's make sure we get this right. It's going to be plus 20. And we get 181 degrees, 181.1 degrees. So it looks to be, it's going to be answer choice C. The other thing you can do is you can take this in a calculator and solve by graphing. That might be a little easier way to do it for some. And you just put this equation in like this, and so you set one side equal to 0. So if we do that by graphing, we'd go right here to y equals, we have 20 plus, we have t sub 0, which is x minus 20, and then we have parentheses, we have times e to the power of negative 0.35 times 5, And if we subtract out our final temperature, which is 48, what we can do is, this is really one of Mason's favorite ways of solving these problems, so I'm doing this for Mason. But we don't see this right here because we don't have enough room to work with. And so I think we need 180 degrees for our window, don't we? Yeah, so let's go to X max of 100 and 199. We're going to go by 10. So we graph. This is what we get. And you see we're crossing the x-axis right over here. What is that going to be? This is what Mason's going to do on this test in a couple weeks. He's going to go, how's he going to do that, Mason? You're going to go second trace, 0, right? Is that right, Mason? That's what you do?
Yes, sir.
So we want left bound. So we go to left bound and press enter. And now it says right bound question mark. So we go to the right and press enter twice more. What do we get? 181.1 degrees. So that's solving by graphing. So that's correct. I invite the viewer also to look at problems 15A and 15B for supplementary practice. Good luck, and thanks for viewing.